Greatest Common Divisor. The greatest common divisor, or GCD, is also called the greatest common factor of two numbers is the largest number that divides them both. For example, the greatest common factor of 20 and 15 is 5, since 5 divides both 20 and 15, and no larger number has this property. The GCD of several numbers may be computed by simply listing the factors of each number and determining the largest common one. For example, find the greatest common divisor of 30, 36, and 24. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. The second one, 36. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18, and 36. The third one, 24. The factors of 24 are 1, 2, 4, 6, 12, and 24. The largest number that appears on every list is 6. So this is the greatest common divisor. Let's simplify. GCD of 30, 36, and 24 is 6.
Prime factorization. Prime factorization. Prime factorization is finding which prime number multiplied together to make the original number. This is the example of prime factorization. You need to multiply every factor to get it prime numbers, which is 2 times 2 times 3 is equal to 12. 12 is the prime number. The factor is 2 times 2 times 3.
To use this method on getting the GCD, first we would need to find the prime factorization of each number. For an example, we would need to find the GCD of 24 and 60. For the prime factorization of 24, it is 2 times 2 times 2 times 3. Now for 60, it's 2 times 2 times 3 times 5. The common prime factors are 2, 2, and 3. The greatest common divisor of 24 and 60 is the product of these common prime factors. 2 times 2 times 3 is equal to 12. Let's use another example. Let's find the GCD of 40 and 64. For the prime factorization of 40, it is 2 times 2 times 2 times 5. For the prime factorization of 64, it is 2 times 2 times 2 times 2 times 2 times 2. Now that we have the prime factors of 40 and 64, we would need to find the common prime factors. It would be 2, 2, and 2. The greatest common divisor of 40 and 64 is the product of these common prime factors, which is 2 times 2 times 2 is equal to 8. Pag ating kinukuha ang GCD gamit ang prime factorization, madali nating na makikita ang common prime factors at atin na lamang i-multiply ito para makuha ang sagot. Division by primes. Division by primes is done by dividing all the numbers by the smallest prime that can divide all of them. For example, the smallest prime that divides 24 or 60 is 2. 24 divided by 2 is 12, while 60 divided by 2 is 30. Continue the steps until we can't find any prime number that can divide all the number on the right side. So for 12 and 30, 2 is also the lowest prime number that can divide them all. 12 divided by 2 is 6, while 30 divided by 2 is 15. For 6 and 15, the smallest prime number that can divide them is 3, which would result to 6 divided by 3 is 2, and 15 divided by 3 is 5. With 2 and 5 being prime numbers, there is no need to carry on. The numbers on the left side would be multiplied to get the GCD. The GCD would be 2 times 2 times 3 is equal to 12. Let's use another example. Let's find the GCD of 40 and 64. 40 divided by 2 is equal to 20. 64 divided by 2 is equal to 32. 20 divided by 2 is 10, while 32 divided by 2 is 16. 10 divided by 2 is 5, while 16 divided by 2 is 8. Since 5 and 8 have no similar prime numbers to divide with, we would now multiply all the numbers on the left. The GCD would be 2 times 2 times 2 is equal to 8. May pagkakapareho man ang prime factorization at division by primes, mas madaling magagamit ang division by primes sapagkat sabay-sabay mong kinukuha ang mga sagot. Hindi gaya ng sa prime factorization na mano-mano mong gagawin ang pag-factor ng given. Euclidean algorithm. This algorithm finds GCD by performing repeated division starting from the two numbers we want to find the GCD of until we get a remainder of 0. For our example, 2 and 60, below are the steps to find GCD using Euclid's algorithm. Divide the larger number by the small one. In this case, we divide 60 by 24 to get the quotient of 2 and remainder of 12. Next, we divide the smaller number, 24, by the remainder from the last division, which is 12. So 24 divided by 12, we get a quotient of 2 and a remainder of 0. Since we already got a remainder of 0, the last number that we use to divide is the GCD, which is 12. Let's use another example. Find the GCD of 40 and 64. 64 divided by 40 is equal to 1 with a remainder of 24. 40 divided by 24 is equal to 1 with a remainder of 16. 24 divided by 16 is equal to 1 with a remainder of 8. 16 divided by 8 is equal to 2 with a remainder of 0. We would stop here since we already got a remainder of 0. The last number we used to divide is 8, so the GCD of 40 and 64 is 8. Ang Euclidean method naman ay may ihahalintulad sa division by primes, ngunit imbes na gumagamit tayo ng pinakamaliit na prime number bilang divisor, ang mas maliit sa dalawang given ay ang unang nagiging divisor at sinusundan ito ng mga remainder, hanggang ang huling division statement ay nawawalan ng remainder. With these three methods, you can get the greatest common divisor with ease depending on the situation. If you only have two givens, using the Euclidean method would be the fastest. If you have the multiple givens, both prime factorization and division by prime are best suited. If you want to find the GCD faster, use division by prime as you can divide all the given at the same time. If you are in a rush and want to be more secure with your answer, use prime factorization that will utilize the factor tree to get the prime numbers. Thank you for watching. We hope that you learned something from this video.